Thanks, everyone. So today we're going to talk about change data capture and what you can do to drive real-time data capture and transformation with Delta Lake. I've been told to not walk around, and I do like to pace, so I'm going to try really hard to stay stationary here for the folks that are watching online, and great to have you all tuning in as well. So my name is Paul Lacey. I'm a Senior Director of Product Marketing here at Matillion, and I'm joined by a colleague of mine, Paul Johnson, who's the Director of Product for our ingestion products here at Matillion as well. We're excited to get into it with you and talk a lot about the challenges with data ingestion, some of the different strategies that you can use to overcome those challenges, and then we're going to talk a little bit about a demo. I'll start off by telling you just a little bit about Matillion, so we're not strangers to you, and you kind of understand the role that Matillion plays in the modern enterprise data stack, and then we'll get right into it. We'll talk about batch loading and batch loading strategies. We'll talk about some of the shortcomings there. And we'll talk about low latency CDC architectures, and then probably the most fun part, Paul Johnson's going to come up and give you a great demonstration of what you can do. And then towards the end, we're going to talk about the use case applications for this as well. So what can you build on this kind of technology? So I'll start off with just a quick intro to Matillion. So Matillion is a cloud-native data integration platform. It is customized specifically to Delta Lake so that you can take advantage of all of the unique capabilities of Delta Lake when you're operating within our environment. We have all of we have a platform, end-to-end platform with all the technologies that you need to load data from any source. And we'll talk a little bit more about what that looks like. Actually, that's the primary thing we're going to talk about today. Once you've loaded it, you can also transform it with the power of push down into your Delta Lake cluster, and make sure that you do that in a very efficient way. So we are a code optional platform. What that means is that you can take advantage of all the low code capabilities, and when you need to dip into code, you're doing very productive things with your code. So you're writing very specific Python or SQL that's specific to what you want to do with your data and your operations. Well, you take care of all the low-code orchestration that happens throughout the platform, and it also makes it more accessible to more people across the organization. So we got data scientists and analysts working side by side. You can do that with the low-code capabilities, such that everybody can kind of understand very quickly what's going on. We have capabilities to be able to sync data back out into your business applications as well, so you can push it out to places where you want it to go after you've done your transformation and processing. And we handle the orchestration from end to end. But more so than that, Matillion is the kind of foundation alongside Databricks and Delta Lake of what we like to think of as the modern enterprise data stack. Now, how many people here have heard about the modern enterprise data stack? Show of hands. A few people. Okay, we're all building modern data stacks because we are here. We're building on Delta Lake, right? We're building on the lakehouse. But what we think about at Matillion is how do we go further, and how do we guarantee enterprise compliance of the modern enterprise or the modern data stack? So there's a lot of great open source technologies. We're going to talk a little bit about one of them, Debezium, a little bit later on when we talk about Matillion Data Loader. But what we need to do is make sure there's also compliance and governance applied around this, right? So we have security. We can make sure that everybody is doing the right things with data. And the way that Matillion does this is by integrating with lots of other players in the stack that have enterprise-grade offerings like your data catalogs, your data governance providers, data analytics providers, and sharing metadata of what's happening with your data pipelines and data workflows so that those layers can understand what's going on and do smart things for you as well. So you can see things like automated lineage showing up in Calibra based on the code that you write in Matillion and the work that you do in Matillion. Because Matillion understands the SQL pushdown and then shares that metadata up the stack and gives you those kind of integrated end-to-end experiences. So that's kind of how you build a modern enterprise data stack on Matillion. And it has tremendous impact in the real world, right? It's not just theoretical. We see tremendous reduction in time to run jobs when you take advantage of the scalability of the cloud with a low-code infrastructure. We see how quick it is to get new things out the door at especially large, complex businesses. And my favorite example is Uberflip, where they went from 5 weeks to just 1 day to add a new data source into their analytics environment. This is before they were using Python notebooks and Jupyter notebooks to kind of ingest the data and manually run these pipelines and then do all the transformation work. And once they switched over to Matillion ETL, they were able to do that all within a single day. So tremendous, tremendous impact. So let's talk about batch data loading for a second. So when you're starting to build a lakehouse, the first thing you need to do is get data into the lakehouse, right? And then you need to start working with it and doing some interesting things with it. And if you do any amount of research online, you'll run into the most common strategy, which is batch data loading. Now, what this is we are essentially querying a data source at a particular interval and then and computing the delta of the data between the last query and then loading that delta into a cloud data source or cloud data environment like a lakehouse, like Delta Lake. And this is a very common strategy. It's been around for a long, long time. People used to do this cron jobs and scripts, and now there's a lot of great kind of standalone platforms that help you out with this. And we'll also talk about one in a little bit, Matillion Data Loader, which does batch data loading as well. And the frequency at which you refresh your data sets will depend on your application, right? So what are you using this data for in your business? Is it for an annual report or sort of like a monthly report, a board report? Maybe you refresh that weekly. Is it for an operational report that every day your sales team looks at the performance of the pipeline yesterday and makes decisions? Maybe you run that nightly and you refresh that data on a nightly basis. It could be hourly if you're trying to do some sort of a semi, low latency dashboard or other type of application, right? So that's kind of how we do it, and we run queries. The problem is that we're running queries and in particular when we're running queries against databases, this is the type of query that we would be running in a batch data pipeline. So any DBAs in the audience or former DBAs? How many people would be comfortable with this running against their database every hour, especially a production database? A few people, not too many people, right? And then what about every minute? What about every second, right? So as the latency decreases, these types of queries become untenable for capturing data from databases. It adds tremendous amount of load to the database, which has a huge negative impact on its performance. And as you all know, that means that the things that the database is backing can also drop in performance as well. So things like customer-facing applications start to become laggy, dashboards start to become laggy. It's just not a great way to get data out of a database. This can lead to delays in building out your cloud data platform, especially if you haven't foreseen this and you suddenly realize that, oh wait, we need a real-time stream out of this database. How do we do that? You have to stop and purchase new technologies and re-architect things and whatnot, which can cause delays. And it ultimately frustrates people around the business because they don't have the data at their fingertips when they need it, which can be a little bit antithetical. So the solution to this is change data capture. How many folks here have heard of change data capture before? Familiar with it? Quite a few? Yeah. So this is not a new technology, right? This technology has been around for 10, 15 years or so. But what is new is the demand for change data capture. So doing this before used to take a lot of setup. Used to take days, sometimes weeks of setup and constant maintenance, or you'd pay through the nose for a very expensive and heavy installation to do this type of data capture. For those of you that are not familiar, I'm just going to quickly run through and give you a bit of a refresher. So change data capture is the technology that turns a database change log into a stream of events, right? It's literally the change data that happens to the database. So every single write, every single insert, update gets captured in the change log of the database. And then in this case, we have something that reads the database log, not the database directly. We're not querying the tables and using database resources that way. We're looking at the log file of the database, turning that into a stream of events that then you can do stuff with. And that stuff that you can do with it are things like backup and disaster recovery, right? So now you have a complete sequence of events of everything that happened to the database from one point to another. The other thing you can do, obviously, is you can create exact point-in-time replicas of the database and the state of the database at any given time by streaming those events. Very powerful, because the other thing that batch data loading misses is it misses the changes that happen in between the frequencies of the snapshots, right? So if you're trying to do something like fraud detection, or you're trying to detect or train a machine learning model on sort of real-world data sets and data streams, you can't do that with batch data because you're going to miss what happened in between your snapshots. Things can happen at a higher frequency than you're snapshotting the database, and you'd miss that. With change data capture, you get all of that. And there's tons of more use cases that we'll talk about in a minute after Paul Johnson kind of shows us how easy it is to use in the real world. But 80% of people surveyed by IDC said that within the next 6 to 12 months, this survey is now 6 months old, so the next 6 to 12 months, 80% of people that surveyed organizations are going to use change data capture. They're going to bring this into their organization. So this is really pertinent technology. And as I mentioned before, the way we do it is we have an agent that reads off of the change logs of the database. So unlike batch loading, where we're querying the database on an hourly basis, we have a continuous stream now of events that are coming off the database and then going up into the cloud. And that's really, really cool. And you can do some amazing stuff with it. How this looks from a Matillion perspective, I'll just give you an orientation of the architecture. So this is showing Matillion Data Loader, which is our service that lets you load data at scale, but in both batch and CDC modalities, but we're talking about CDC in particular right now because that's new and fresh. We have an agent that lives as close to the database as possible. And that's important for performance reasons. And in this case, this agent is containerized, so it's ephemeral. It gets a set of operating instructions from the SaaS control plane, but otherwise it lives within the customer data plane, within the VPC. So if you're designing architectures for yourself, or you're designing architectures for clients, you can ensure that the data stays within their private subnet. It's not transferring over public networks. It gets everything it needs to retrieve a secret from a secrets manager, access the database, log into the database as a read-only user, and then read the log files and turn those log files into that stream of events that then can be streamed into Amazon S3 in the form of an Avro file. And from there, you can pick that up and do stuff with it immediately. So if you want to start running machine learning algorithms against the data, you can do that right away in the Amazon S3 bucket. If you want to transform it and do some more interesting things with it, then you can bring in our other platform, Matillion ETL, or other service, Matillion ETL, that will help you pick that data up and move that into Delta Lake and transform it along the way as well. And you can do lots of really interesting things with it. This is a reason for this kind of two-step architecture. It doesn't lock you in. It gives you a lot more flexibility on what you want to do with the data. It doesn't just stream an exact public copy into Delta Lake. So with that, let's get on to the fun stuff. So I will introduce Mr. Paul Johnson to give us a demo. Paul, welcome to the stage.
Thank you, Paul. Cheers. All right. Thanks, everyone. Is anybody here using Delta Lake for kind of a traditional data warehouse use case, doing data modeling, anything like that? Nobody? One at the back? Okay. Bear with me 1 second. There we go. Okay, so what I'm going to show you today, a couple of things. So CDC pipelines in Matillion Data Loader. I'm going to how we set that up and what that looks like, what that experience looks like. And then once the data is actually being replicated into a data lake, Amazon S3, we're going to see how we can use Matillion to transform that with Delta Lake on Databricks as well. So what you can see on the screen here is the pipeline overview screen. There's a couple of different things going on here. What we've got is batch pipelines and streaming pipelines, CDC pipelines, all in the same user interface, so we have a kind of a unified experience for getting this set up. The one at the bottom you can see here, we're going to come back to this one in just a moment. This one is replicating changes right now from Postgres to Amazon S3. But before we go in and have a look at that one, I just want to show you what the experience of creating one of these pipelines looks like. So Paul mentioned the agent, which is based on Debezium, an open source project, the most popular kind of change data capture project out there. There's lots of companies using it, but also lots of vendors have built on top of it, including Matillion. So once you install this containerized image, which is what we call the agent, you connect it to the Matillion platform, and once it's connected, you'll see there that you can connect it to a pipeline. That's where we're going to pick this up now. So I'm going to connect to the Postgres database. And what I'm going to do here is basically give the connection string details to the agent so it can connect through there. So I'm just going to populate some of these details here. And Paul mentioned in the architecture diagram you just saw there, we use a secrets manager for getting the credentials. So the Matillion platform is SaaS. The agent is running in your own environment. We don't necessarily want to put password over that network. So we just tell the agent, here's where the password is. It's in the secrets manager. Go and retrieve it from there. OK, so I'm just going to test this. And that's basically the agent now saying, I can connect to the Postgres database. Once you've done that, you just need to select which tables are going to be a part of this data pipeline. So we've got 4 tables in there. We'll just bring them all over. Some customer information, items and orders. And then we're going to say, where do we want to replicate these changes to? So what's happening inside the agent here is we're taking the change log, and it doesn't matter if it's a Postgres or an Oracle or a SQL Server or whatever it is. By the time it lands into the S3 bucket, it's in a standardized format, so they all look the same. Doesn't matter which database it's come from. So you get lots of interoperability between downstream systems. And we put that in Avro kind of optimized files there. So I'm going to connect to the S3 bucket here. Put this in there. And then the final thing to do is just to give it a name, right? And we can go and create that pipeline. But I mentioned the one that is already running, which is actually moving data right now. So you can see it goes into snapshot mode, depending on how big the current database is. That will depend on how long the snapshot mode's, and then it will automatically revert into streaming mode, which is what's happening in this one at the bottom. So we haven't actually showed you any data of what it actually looks like. So the first thing I'm going to do is just have a look at the S3 lake, where this pipeline is set up to. So it's got this basically partitioned bucket, which has the tables in there. So we'll just pick on this customer one. We can go down there, and you can see it's got this date partition system. So you can see down to the hour all the changes in there. So you can see there's some Avro files being created for the particular timestamp that it was in there. So now I'm going to just switch over to Matillion ETL. And I'm going to show you what the data looks like within the unmanaged tables, and then how we can get that over from kind of that bronze raw layer into the kind of silver and potentially even gold kind of managed layer. So I've just got a component here which will allow me to look at this raw data. So how does that look on the screen? Let me make it a little bit bigger. What you can see in here is the before, the after, and some metadata, and then that date partitioning. So if I just make this a little bit bigger so you get an idea of what's actually in there. There's no before data, so that tells me this is a new record. It's an insert. But that information is also enclosed in this kind of JSON structured data there. Now, that's great, but it's not particularly useful in this state. What we want to do is to turn this into a bit more of a structured table, so then we can do some typical data warehouse use cases. We can model it, we can get it ready for analytics. Maybe it's a dashboard that we want to build, something like that. So there's a component in Matillion, which is just called the sync all tables. And what this component does is it runs one of a couple of transformations. So I've chosen the changelog transformation, which is basically going to do an insert-only append onto a permanent table. So you've got an audit history. You could choose some other options. So you could just do a copy, which would just make your Postgres table match the target table, an exact replica, which is always in sync. And then there's the same thing, but with a soft delete mechanism. So if something gets deleted in the source, it just gets flagged as deleted in the target. But I'm going to go with the changelog approach for this one. And once this component is run, the output of this is what we see over in this kind of this sample job here, which is going to build up a silver kind of. It's actually going to we're going to do a bit of a data vault modeling exercise. So what we get after that is we take that raw unstructured data, we put it into a structured table. We've got the actual data from this customer's table in there. We've got it's a Unix timestamp, and then we've got some metadata as well. So when I'm modeling this for data warehouse, and the modeling methodology I'm going to use here is data vault, we need to generate some fields that are required as part of building these entities out. So we need to get the business key, we need to get the record source, and things like that. So what Matillion can do is it can very quickly generate these for you. So we're just going to generate 4 fields. We're going to make a hash key based off the business key. We're going to have the timestamp, which is going to convert that Unix timestamp into a readable timestamp, and then we're going to take some metadata columns and make the record source there. Once we've done that, we're just going to create two tables, essentially. So we're going to have a hub and a satellite for this customer table. Here we go. We have those generated keys. And then for the satellite version of this customer table, which contains the descriptive data, the attributes, we've got the first name and last name there. And then you can go and create those as tables or as views inside Delta. And then you could then further model that into star schema or something like that, which you could then use for kind of BI reporting and those kind of things as well. Okay, so pretty much done with the demo there. I'm going to ask Paul to come up quickly, give us a little outro, and then we've got a Q&A session, so hopefully I'll stay on stage and we can take some questions.
Sounds good. Thank you, Paul. So I just wanted to close out by sharing with you, I know I promised, some of the applications that you can use with, or that you can build with this kind of technology. So, and by far not a complete list, right? The number of applications that you can build is growing every day as people innovate. But a few of them, a few noteworthy ones. So the first one is cloud migration. Oftentimes when you're migrating from a legacy environment, you'll have operational data sets that are being hosted on-prem in Microsoft SQL Server or Oracle database or something like that. And you need to replicate you need to replicate that data into the cloud before you can do things with it in an interesting way. This makes it possible to do that without having to migrate your entire infrastructure to the cloud in one fell swoop. So you can maintain legacy operations and business as usual in sort of your on-prem installations, but then you can upload this to the cloud in real time. You can mirror this data in real time to the cloud and start to do interesting things with it in Spark and Delta and other platforms that are there. And then with the Matillion syncback capabilities that we mentioned earlier, you can actually take data out of Delta and put it back into Oracle database, back on-prem. So you can have a round trip through the cloud for this data where everything stays in sync, and you're able to bring the power of AI and machine learning to your legacy systems. So you don't have to, again, migrate everything to the cloud in order to get the benefits of the cloud. So that's super powerful. Obviously, you can do really interesting things with operational analytics and turning a database into an event stream. You can post that event stream to a message queue, and you can have sort of real-time applications that respond to that message queue, which is quite interesting. You can do fraud detection, as we mentioned before, because now you have every single change that happened to the database, so you can understand even small ephemeral events that happen that are based on a fraud attack or an attack vector. You can understand those in real time, and you can also train AI and ML based on that data historically. So if you want to train a model that feeds on live data, you can train it on a historical change log of a database as if it was a live data stream, which is super interesting. And then finally, there's some basic use cases of, obviously everybody thinks of marketing analytics, right? Everyone's trying to drive ROI at the end of the day. So you can imagine ingesting data in real time from your inventory, from your other operational analytic or operational data stores, and then putting together real-time campaigns that are highly targeted on the web and in other channels, and supporting other use cases like auditing as well. And all of this is made possible, but we were showing you today, by the Matillion Data Loader platform, Matillion Data Loader service on the Matillion platform. And so we showed you what Paul showed you is how easy it is to create pipelines on the Matillion Data Loader platform, and that you can create both change data capture and traditional batch data loading pipelines in one place. You don't have to switch back and forth. It's super productive. You have a one-stop shop for all your data loading, and it's all done in a no-code way. So it accelerates time to value for engineers, so you can work on more interesting problems across the business. We'd love to talk to you more at the booth to tell you about our no-code connectors for building out new SaaS API connectors in minutes. So we can definitely show you that at the booth. And we, as you saw, all of this is enterprise-grade technology to support the modern enterprise data stack and the way that we deploy it in a hybrid architecture. So the data is never passing over a public domain. It's always within the private subnet of an environment that you control. So with that, that's what we had for you all today, and we'd love to take some questions. Paul Johnson here is our resident expert in CDC, so if you have questions about change data capture, we'd love to hear them. And I think we might have had a question towards the front at the beginning.
And I was wondering about why 2 hops. So why not Delta Lake right at the start of the CDC tool so that it can be consumed readily by any ready consumer like Databricks or anything? Like why the bronze layer is a JSON blob and so what was rationale behind that kind of design?
So if I just make sure I understand you right, why didn't we just go straight from source to replicated table? Why do we do the data lake stop in the middle? That's a good question, and there's a couple of reasons that we do that. So one is you're not basically locked in with our process. So if you took another CDC product that does that, that whole logic of taking the data from source to target is kind of locked into that system then, that vendor. So we are completely interoperable with other technology, right? So once it's in the S3 layer, you can put Delta Lake on top of it. You could put SageMaker on top of it. You could use any kind of technology because it's done that initial hop and it's not all the way locked into that end state initially. Most use cases, though, they probably do want to go all the way. So that's why we've made it really easy just to go from that stop from the data lake to the table state.
If I'm not mistaken, Paul, I think another reason is that when you use a traditional service that goes all the way through to replicate, it can be a little bit complex to do non-standard things like soft deletes, for example, to configure soft deletes if you wanted to not have a hard delete or an exact mirror replica. With this, you get a lot more flexibility in how you want to set up your pipelines because you control that. It's sort of like seeing into that layer of the stack or of the service and being able to tinker with it. Paul, I don't know if there are others that I missed.
No, it's a really good point, actually. So you just get the extra options that are enabled. So by having it in the data lake, you might want to do data warehousing on it, which is typically what CDC products do. They take it one table to another, you get a data warehouse. But you might just want to do some exploratory analysis on it, why it's in the lake before it goes down to that stage. So by breaking it down, you get those options. And it also follows the kind of modern paradigm of loading data ingestion. So you go to the object storage layer, and then you do a load into the target state. So it's kind of a bit more of a modern ELT style approach to that.
So this silver is, the bronze is fully immutable.
Exactly, yeah. It's like a permanent, in that demo there, we did like an append-only kind of record, so it's just a huge audit history table.
Other questions?
I have one more question regarding, in this Matillion, you have the capability to do the CDC, but how would you convert your data events to a business event? If we want to join a event streaming and CDC in one pipeline.
So how do you join those two things together?
I mean, if I want to do an architecture which can handle two of them in one umbrella. So question is, in CDC, your data is coming on different time, and how would you stream it together?
Yeah, so if the rate of change is different in one's table to another,
yeah. So for example, you have a vendor and you have a vehicle and a damage, and then now you want to process them in one order, so you need to do some sort of synchronization, and you want to make sure those events are falling, or if it's a CDC, they are falling apart enough so you can process one and not bumping on each other.
Yeah, so one of the key parts of that is how we maintain the correct order of the changes, which is hugely important, right? So if we stitch the data back together in the wrong order, you get some serious problems if there's a delete ahead of an update and stuff like that. So there's a couple of ways that we do that. The Debezium agent has a way to handle that itself, but we've also enhanced that functionality within the Matillion agent. We maintain an offset, which is based on a unique combination of fields, so it can basically never be out of order. So one way we keep things in sync is making sure the updates are applied in order. And then in the demo there that I had 4 tables, so there's like an order, an items, and customer, and something like that. They were all within that same pipeline. So even if one is changing much slower than the other, the changes are coming through in the right order. So when we get to the transformation stage and we do that processing, everything is in the order that it happened in the source. So if you wanted to join a customer to an item or an order, for example, you could easily join those two together because the data has been updated in the correct order and at the correct frequency.
Right. And what is the latency we are promising here?
Well, it depends on a number of factors, network connectivity and things like that. But we do internal benchmarks every day, essentially, on the databases, and we make sure that we do at least 30,000 records per second coming from those change logs. It can be much higher, but that's like our kind of quality gate that we have internally.
Thanks.
Great. Other questions? Got a question over there, I think. Yeah.
So you mentioned cloud migration. We are working on cloud migration from Hadoop to Delta Lake. And the plan is to have both systems running in parallel for a couple of months. I know you also mentioned syncing of the data, and one of the problem that we're trying to solve is how do we make sure both systems are in sync?
Yeah.
Is that?
Yeah, it's a good question. So we actually have one of our customers doing this. Basically, they have a multi-year migration happening. So it's probably going to take them 3 or 4 years to get all the databases into their cloud platform. They're doing it in stages. So usually the first thing that's happening is they're going to take the transformation logic from the on-prem system and put that into the cloud first. So you can use change data capture to get the data into the cloud, run the transformation, and then we can take the data that's now transformed and then put that back into the original database with some of the sync connectors that we have as well. So you could take the Postgres data, replicate it, run the transformations, and then take the output of that back into the legacy system while that still needs to run for a number of years before it can be kind of sunsetted or that kind of thing.
Okay. Thank you.
Great question. Any last question from the audience? We got one?
Hey, like 2 quarters back, I was working on a requirement where we were looking for geo-replication with Databricks. And at that point of time, Databricks didn't have that option. I didn't know if they have an option now. But the requirement was like if there is a tool where Databricks can be the source, like I see Matillion has Databricks as the destination for sure, but can Matillion be used for taking Databricks like Delta format or whatever within Databricks as the source and do a geo-replication or like help for geo-replication?
Yeah, so it's a common and emerging use case that we see, which is basically the cloud data platform becomes the center, the hub of all of the kind of data applications and things. So not only does data need to get ingested, but it needs to get operationalized back out into these other systems as well. So we've got a whole suite of connectors in the Matillion ETL product that allow you to take that data and push it back into your CRM system or your SQL database or whatever it is.
Okay, yeah, thank you.
Great. All right. Well, with that, we'll go ahead and wrap. Thank you, everybody. We'd love to chat with you if you're interested at the booth. We're downstairs at the expo hall right as you come through the entrance on the left-hand side. But otherwise, thanks for your attention and have a great show.
Thanks, everyone.